The following research is part of the National Institute for Congestion Reduction funded by the United States Department of Transportation through the University Transportation Center program. Learn more at www.nicr.usf.edu.
Welcome to Out of My Lane, a podcast of the Center for Urban Transportation Research at the University of South Florida in Tampa. I'm Wayne Garcia, your host. I'm with Rakesh Rangaswamy, who is a doctoral student in the USF Civil Engineering program. He's done quite a bit of work with Qatar because his specialty is transportation engineering. Rakesh, welcome to Out of My Lane.
Thank you.
Rakesh received his master's degree in civil engineering from the University of South Florida here in Tampa, where he studied various things related to transportation, all the way from traffic engineering systems, pavement design, asphalt mixes, all the hands-on and all the engineering thinking stuff. He's pretty much done it. So in this episode, we're going to look at Rakesh's journey to his PhD and his various research projects that he has worked on. So again, Rakesh, thank you for coming in. In the second season, we're doing a number of the engineering students who take part in Qatar and really provide a lot of the important legwork research while they're also receiving their advanced degrees. So we start each episode with our icebreaker.
Okay.
And the icebreaker is, since the pandemic, it's been different for everybody. Tell us about your daily commute to school here.
I mean, from pandemic, my commute really didn't change because I was to do data collection. So every day I had to travel to USF and I had given the travel authorization from the DOT to go and collect the data around the Florida state.
So you've been all over the state.
Yeah.
So a daily commute might be a drive to South Florida.
Yeah, but now currently I'm working like an internship at Florida Department of Transportation, FDOT, just right across USF. So, and I stay in on 50, which is across USF again. So it's not too far. It's just like 5 minutes commute for me.
You've got the real easy commute.
Yep.
That's great. And so how did you get interested in engineering? Of all the things you can do, what appealed to you about that?
Okay, so basically my whole family were into civil engineering thing back in India. So I'm from India. So my dad is a civil contractor and we have a family business. We do solid waste management.
Uh-huh.
So from childhood, I'm kind of aware of like all these civil engineering concepts. But however, like as it's a family business, once you do, so like after you finish your associates or something like that, they would put you to the family business. But my dad was like, listen here, money you can earn and it comes and it goes. But education, it always stays. So it's very important for you to get, get educated, go for engineering, look at what you want. Just don't jump into the business and think about money. So I took a different route in the family, and the familiar subject was civil engineering for me. So I was like, okay, let me go take associates in this, and let's see how it goes. And I started. So in India, it's called as a diploma. So I was doing, and my major was construction technology and management. So that's how I started my civil engineering journey. And later, after I graduated my associate, I was working as a structural draftsman, AutoCAD drawings, and I was also tutoring AutoCAD in CAD Center. It's in Malaysia, in Bangalore. There I met an interesting guy. He's a very well-known structural engineer, and one day he had come to do like a career fair in the AutoCAD Center. I went to him and I was just, sir, I had a couple of questions like, I do all these drawings, but some of the details I don't understand. What exactly is this? I asked him. He's like, what's your highest degree? He said, sir, associates. Associates. And you do all these drawings? And you don't know what is this? He was like, yeah, I'm kind of aware. Like, I know what is one-way slab, two-way slab, how you give the reinforcements. I'm kind of aware of it, but I don't know like in depth. I know only about like compression, tension, shear. I know these are the loads which acts. That's it. Then he said, okay, once stop by my office. We'll discuss more about this and let's see what you have. And I went to his office. Then he gave an opportunity to do like a part-time job in his office. So I started as a structural draftsman there. After I started drawing, he said, I think after 6 months, he was like, you know what? I strongly suggest you to do like bachelor's. It's very important for you to know, because just associates and knowing the AutoCAD tool is not gonna take you like to a long distance.
Where
Yeah.
you want to go.
Yeah. So you will have to, take your bachelor's. So I did my bachelor's, and later I was like, okay, next is master's. And I just applied for University of South Florida, and I came here. But how I got into transportation, that's more interesting.
Well, then tell us, because of all the different genres or subfields in civil engineering, and there are plenty of them, how did transportation show up in front of you?
So I applied here for structural engineering, but here and there in my first semester I was taking transportation classes too, because those are some of the requirements also. So I was taking a couple of their classes. I think it was Dr. P. Sanglin's class. So I was like taking his class, and it was answering to couple of my questions which I had from the childhood. I had some questions like, how does these signals operate, like from red to yellow to green? Who decided it? Okay, we have the speed limit. Who is telling me to follow this 45 mph? Like, okay, this I-75, like I came to United States, there is this I-75, there is this I-275. Like, who built all these roads? Who are the people behind all these things? And the most best part was, I didn't see any traffic engineer, like traffic police. Like usually, back in India, there will be a traffic police who will be like directing everyone. But here, I didn't see anyone. In a four-way stop, without signal, people, they would just stop. I mean, they would yield, let the other person go, and they would go. I was like, wow, this is like interesting. Like, how do they make all these things happen here? And this subject, which I was taking with Dr. Pisanglin, it was answering all those my answers which I had. Like, this is how you calculate, the speed. This is how we decide the speed limit. It was traffic engineering. Then I started taking more classes. Then one day I stopped to him and I said, sir, like, is there any job opportunity at your
In this field?
yeah, in this field? He said, why don't you stop by my office? Let's see what we have. And he took an interview. He said, okay, we have some graduate research assistantship. If you are willing to do, let's see what you have. Let's see how it goes with you. I started working on a small project, and that's how my transportation journey started.
Oh, wow. The mysteries of the universe were revealed to you. That had to feel great. So now we skip ahead. You get your master's degree, and now you're working on your PhD and doing lots of research, working with some of the Cutter professors. So let's talk about some of the projects that you have done and that you're working on now. So your most recent one, it looked like, was about wrong way drivers. And for those listening who are not in Florida, although this is not just a Florida problem, but it does seem to be, we have a lot of them in the Tampa Bay area.
Oh, that's true.
And it's a very bad problem. People getting on highways the wrong way. They're either impaired, they're lost, something happens. So you have been working on a research project looking at wrong way drivers and whether various treatments or barriers or different things are effective in cutting down on the number of people who get on the highway going in the wrong direction. How did you get started on that project? And tell us a little bit about how the work has progressed.
Okay, so currently I'm working on this wrong way driving. It's FDOT project, but Dr. P. Sanglin again. So under his guidance, I'm working on this project. As you know, like wrong way driving, it's a rare event. It doesn't happen, like frequently like other crashes. So it's a rare event, but still, like the fatalities or anything, it's little higher when you compare. If you really look at this wrong way driving, imagine, like you are watching a TV with your wife or something, and you fall asleep. So if she wants you to wake, she will like either wake you up or like call you by name and wake you up, right? Like, hey, you're missing this scene. Come on, see. So same way, that's how. So right now, wrong way driving, there are like FDOT, like other DOTs have taken so many countermeasures to find a right way to make these drivers be attentive that they're in a wrong way, going in a wrong direction by posting those signs, or like giving the speed limits or giving some warnings or something. But still, DOT is like, I think we should find some other ways to make these drivers little attentive. So now I will connect to that TV thing which I was saying. So we were like thinking, how about we make these drivers, like make them little attentive by making some noise through some noise or through some vibration. So we're like, okay, because most of the time wrong way drivers, like who are not distracted, they will see the sign and they will get on the right way. But some of them are like maybe they're impaired by alcohol, or like they are inattentive, they are
on their
distracted.
phone or
Yeah, they are
something.
on their phone. So they need to be like made aware of that they're going in a wrong direction. So we are using this particular like a strap when these drivers go on whatever the posted speed limit or like higher than the speed limit. So it vibrates the whole vehicle, and also it makes a noise, and it makes them like it makes them attentive and like to know that they're in a wrong way, and they can look around and see, oh, I'm in a wrong way. So that's one of the countermeasure. That's one of the like subtopic of this project which I'm working on. So we tested in Pinellas County. I mean, not outside the road yet.
Yeah,
It's
yeah.
in the test beds we are trying. We tested in the D7 also, D7 office also, and we have got pretty good results from that because the vibration level or the noise level, it's good and it's going on.
It's enough to snap
Yep.
people out of that reverie, whatever that is, distraction, drunkenness. Maybe they're having a medical event of some
Yeah,
kind and they
anything.
can't really figure it out. There's a lot of different reasons. Everybody kind of thinks it's DUI related, but it's not always that. There's other things. So when does that project finish up? Are y'all going to be testing out on the actual roads eventually?
Yeah, I mean, testing on real roads, it's going to take some time because, anything happens, the DOT is going to be liable. So it's going to take
Safety
some more time.
first.
Yeah, safety
Safety
first.
first.
So we need to test first. We are using different types of vehicles, like driving on different types of SUV, because SUV, sedan, or even motorcycle vehicles, everything makes a difference with the noise because the tire size is different, everything is different. So, and in the morning time, evening time, like we have to test for like so many scenarios before we say, hey, this is a right countermeasure.
And it can save
Yeah,
lives.
yeah, because we are gonna use at the end of the day taxpayer money, right? It has to be used in a right way. So that's why it's gonna take couple more, like months to finish up
So
this.
that seems like a lot of responsibility
Yeah, I
for
know.
a fairly young guy looking for his PhD. And this segues me into where I wanted to go next, which a lot of your work has to do with safety. It's
Yeah.
not just kind of construction issues or planning issues. It's directly involved with saving lives. So how does that make you feel in terms of your mission as an engineer?
Oh, as you said, this is a responsibility. Luckily, I have really good colleagues and researchers like Center of Urban Transportation and Research. Like there are really some experienced people sitting there who guide you. You won't even think in that line. So they will show you, hey, actually, did you see like you can also find a solution in this way. They guide you very well finding solution in different ways for this problem, and they'll teach you like what all the different ways you can actually see this problem, like a user side, from a researcher side, from an investor side, from a DOT side. How do you see this problem? So if you go take this to the public, how are you going to convince, hey, whatever I've done is right?
Yeah.
How are you going to do that?
You need their
Yeah,
trust.
that's what they teach you in the Center of Urban Transportation and Research. And I feel like transportation engineering is more than what I was like thinking, because it's so much equal to other first responders, like how they save lives. So we are also like directly or indirectly, we are responsible for saving lives. We make an impact on others, life, because we help them creating guidelines how you have to drive, or see their crash report, see the trends. Like transportation engineering is a lot.
So you've done a number of other projects, and I'm not going to read them all out here, but what's been your favorite work that you've been involved with since you've been a graduate student here at the University of South Florida?
I mean, there are two. I have two favorite projects.
Okay, that's fine. You're allowed.
Okay, work zones, crashes in work zones, because that's my PhD topic too.
Okay.
So that's my favorite. So what we are doing is we tested a device. It's called Active Work Zone Awareness Device. So this device has a radar. It's like a dynamic speed feedback sign. So it will see what speed you're going in, and it will catch that speed, and it will start. If you're over the speed limit, posted speed limit, during the work zone, it's going to give you some feedback. And also there will be signs saying, hey, like there is a law that you will have to go slow or you'll be fined, something like that. And there will be also blinkers which will keep constantly blinking when the work zone is active. So what we did is, like, we tested this device on different part of Florida roads, mainly arterial roads, because there are so many research done on highways, freeways, and all. But in arterial roads, there are still more research needs to be done with work zones. So we wanted to test if this device has an impact on drivers before entering the work zones, because in work zone there are workers who are working, so we want to make sure even they are safe in the work zone area, and also there are no any like major crashes. So we what we would do is, like, we would place this device before the work zone starts, like whatever the standard distance, and we would collect data in 2 points while the vehicle is speed spot data while they are entering the work zone, before they enter the work zone, and when they are in the work zone. So like this, I collected, I think, like 7 sites during the whole pandemic. That was my job.
Were you out on
Yeah,
the highway
I was
with
on
the
the
sign?
yeah.
Yeah, okay.
So we had this sensor, smart sensors, which we like that was my job. Like
Yeah.
early morning, go
Yeah.
8 o'clock, put the before the peak hour traffic starts, put these sensors, and also put cameras in these 2 spots, and keep seeing and keep changing the camera, like the memory whenever it gets. And Florida is so hot. Sometimes this camera would just turn off because of
Yeah, it's
overheating.
yeah, it overheats.
So it was really
This sounds like a
interesting.
winter project.
Yeah,
But you
actually,
have no choice, right?
it also got a couple of awards. It was recognized in federal level too.
Nice.
That was nice. Like the D7 was awarded. Like I don't know exactly what was that award name, but they were awarded something for taking this initiative and testing this device.
So, and I think most of us, as we whiz by at 80 miles an hour on a highway and there's some construction, we don't always be as considerate of those people working. That's going to be terrifying. I mean, I've actually, back when I was a newspaper reporter, I've been out there on those sites, and being on the ground on a highway or on arterial road or anything is so much more scary than being surrounded by all this metal as you're driving. So that sounds great.
That's why we also tested the device with different scenarios. We had device itself with no device, device with sheriff, with law enforcement,
Yeah.
how the drivers would respond. The device plus law enforcement gave us the best result, because all these drivers were slowing down to 25 mph before even they started entering the work zones. So the workers also felt safe, and also the drivers.
They're not always looking over their shoulder, which probably is a little more productive for them in terms of getting their jobs done. And then you said you had a second favorite. What was that one?
Oh, it was automated pedestrian detectors. So that I tested in and around USF campus itself. So DOT was interested to know that our pedestrians, because pedestrian crashes, like they are vulnerable users, the crashes was little high, fatality rate was little high at some point. So they wanted to see what exactly is happening outside, especially in the near the intersection or like non-intersection area. What exactly is happening? Are these pedestrians pushing the push button? Because most of the time, as a pedestrian, you would feel like, man, I'm pushing this forever.
Nothing's happening.
Nothing is happening here. So we came up with a solution. How about you don't have to push it? You just go stand there, and there will be a sensor which will detect you,
detects you, yeah.
and the signal phase will automatically gets activated. So that was the solution what we did. So we had these automated pedestrian detectors. We put in like designated intersections, and we saw. First, we did a study where how many pedestrians were pushing the push button before they started using the crosswalk. And after that, we put the sensors and checked. We tested for different scenarios, like using an umbrella during the rain, like different conditions again. And if we have for example, if we have a person, like disabled person in a wheelchair, so if he comes, or if he's wearing like a hoodie, or is it still gonna detect you? So we did so many scenarios, and we did the research, and we got some good results too. So they work actually, but still little more technology. We need to work on the technology to implement them on the
On a larger
actual,
scale,
on the
yeah.
larger scale, because like, so many intersections,
Yeah, that's the
so
problem.
much investment.
Yeah, and so you find this great research, but then, public policy has to catch up to it. So welcome to the wonderful world of public affairs. You've been down this journey. What would you say to a young person who is thinking about a career in engineering, maybe even transportation engineering? What advice do you have to them?
So literally, we were having this expo, engineering expo, last weekend. I'm also a member of like student IT chapter, Institute of Transportation Engineers, USF IT. So we were having these traffic signals and controllers, and we were explaining all the students like how signal works. You know how big these signals are, like 5 feet, but you think it's just like a 3 feet or 2 feet signals, but they're so big, they're so massive. And I was telling them what civil engineering, it's more than you think, because civil engineering is just not building the houses or doing some constructing the bridges or like highways. We deal with drainage, we deal with environmental issues, we do air trafficking, transit, you name it.
Yeah.
We have so much responsibility. We need so many people to work on all these different fields, and all this comes under civil engineering. So I was like saying, once you graduate, you should really take a look at this civil engineering once. Wow. And you might find something interesting, which like I found transportation engineering was very interesting for me. So now we have autonomous vehicles. So you will also get opportunity to work with different fields, like with electrical engineers, with programmers. So you will learn so much, even in civil engineering, like taking the civil engineering. So I encourage everyone to once take a look at civil engineering, and there are so many fields within civil engineering, and you should take them all and make a change.
And especially we've talked about in a previous episode last season about attracting women into engineering. How was the expo crowd of young students? I know I saw some video of lots of young kids, and there were lots of girls and boys there as well. So was there a lot of excitement for
Oh, yeah.
for engineering and STEM?
No, that was actually surprising, because I think a couple of, I don't know if they're parents or like teachers of those two kids, I think they found it interesting when I was showing the controllers, like how the signal works, how the phases work. I think they went and informed the other students, and they were actually, I was in the downstairs lobby. They're looking, hey, so where is this signal thing? We wanna check it out.
Everybody started showing up, wants to see the
I was
toys.
like, wow, they're interested. Then I would take them and show them all these signals. And actually, like students were like, wow, now I'm not gonna see the roads the same way. I know something.
That's awesome. Well, we've been here with Rakesh Rangaswamy, who is a PhD student here at the University of South Florida in civil engineering, does a lot of work with the good folks at Cutter who bring you this podcast. So for Rakesh, again, thank you so much for coming in. It's been a delight to talk to you.
Thank you. Thank you for giving the opportunity. And this is my first podcast,
Very good. Well, very happy to give you that opportunity. I'm Wayne Garcia. I'm your host. This has been Out of My Lane, and we look forward to seeing you next time on the streaming platforms of your choice. Thanks so much.
The National Institute for Congestion Reduction, NICR, is a transportation research center focused on innovative congestion strategies. The center is composed of researchers from the University of South Florida, the University of California, Berkeley, Texas A&M University, and the University of Puerto Rico at Mayagüez, and funded by the United States Department of Transportation. For more information, please visit www.nicr.usf.edu.